If you've ever wondered how an app turns a button click into exactly the right rows in exactly the right order, that's the skill we're building today. In the next few minutes we'll go from installing SQLite to writing filtered, sorted, and summarized queries, 5 short lessons that build on each other, all typed straight into the SQLite 3 command line. We start at the very bottom, getting SQLite installed and opening your first database file, one command at a time. SQLite is usually one command away, homebrew on Mac, apt on Linux, or a downloadable tool on Windows. A quick version check is the fastest way to confirm it's actually installed before you write a single query. Opening a database is really just naming a file. If school.db doesn't exist yet, SQLite creates it the instant you write data to it, not just from opening the file alone. Turn on column mode and headers the moment you open this shell. The default output is genuinely hard to read otherwise. Commands like .tables and .schema let you peek at what's already in the database without writing any SQL at all. Create table, insert, and select each get a full module later. For now this is just enough to prove the whole loop works. Define some columns, load a few rows, and read them straight back out. It's the semicolon, not the line break, that actually ends a SQL statement. That's why a query can wrap across several lines. Comments come in 2 flavors, # for one line and /* for a whole block, exactly like many other languages. Once your SQL outgrows a one-off line in the shell, save it in a .sql file and run the whole thing non-interactively. And because the database is just a plain file on disk, quitting the shell doesn't lose anything. Reopen it later and every row is still there. Your database is live and readable. The exact same shell now becomes the tool for everything else in this video, starting with how select itself really works. Select is the workhorse of SQL, and it does a lot more than just echo columns back exactly as they're stored. Naming exact columns instead of reaching for * is a habit worth building early. It's explicit about what a query actually needs, and it won't quietly break if someone adds a new column to the table down the line. * is fine for quick exploring, less so in real application code. AS renames a column in the output. It's technically optional, but it's what keeps your result sets readable, and it becomes essential the moment you start selecting computed values instead of plain stored columns. Select can compute values on the fly, not just read what's stored. Multiply a price for tax, subtract a year to get an age, or glue text together with double pipes to build a single readable citation string per row. Distinct strips out duplicate rows, and the detail people miss is that it applies to the whole selected row together, so selecting 2 columns with distinct only removes rows that match on both of them at once. SQLite is unusually relaxed about types. A column has a preferred affinity but will still accept almost anything you insert into it. Other databases enforce type strictly, so cast is the portable, explicit way to convert between them anywhere you're writing SQL. With select fully under control, the next question is naturally how to only look at the rows you actually care about. Filtering is where queries start feeling powerful. You tell the database exactly which rows qualify, using logic you already know from everyday math. The basics are equals, not equals, and the greater than and less than family simple on their own, but they're the building blocks every more complex filter is made from. And/or combine conditions, but and binds tighter, exactly like multiplication binds tighter than addition in arithmetic. Mix them without parentheses and you can silently get a totally different query than the one you meant. Always parenthesize when they're combined. Between gives you an inclusive range in one clean expression instead of 2 comparisons stitched together with and. In checks a value against a whole list at once, which reads far better than a long chain of or conditions strung together. Like matches text patterns using % for any run of characters and underscore for exactly one. And you genuinely cannot test for null with the plain equals sign. Null means unknown, so is null and is not null are the only way to check for it. Real filters usually stack several of these together. Here we ask for sci-fi books published between 1950 and 1970 that also cost under $10, combining an equality check, a range, and a comparison in a single where clause. Once you can pick out exactly the rows you want, the natural next step is controlling what order they come back in, and how many you actually see. Two small clauses, order by and limit, control almost every top 10 or most recent feature you've ever seen in a real application. Ascending order is the default, so you only need to write ASC to be explicit about it, and desc to flip it around. Nothing exotic here, just remember the sort direction always follows the column name it applies to. You can sort by more than one column, and each one gets its own direction. This sorts genres alphabetically, and within each genre, sorts by publication year newest first. Ties in the first column get broken by whichever column comes next. Limit caps how many rows come back, but it's nearly meaningless on its own, since without an order by you have no guarantee which rows you'll actually get. Always pair the two when the specific rows matter. Offset skips a number of rows before limit starts counting, the classic pattern behind page 2 of any list. It's simple, but it has a real cost at scale, since the database still has to walk past every skipped row to get there. The clause order in a query is fixed: select, from, where, order by, then limit, so you filter first, then sort what's left, then take just the top few rows, all in one readable statement. You can now slice, filter, sort, and page through any table. The last piece of the foundation is summarizing all those rows into meaningful totals. This is where SQL starts feeling like a reporting tool, counting, summing, and averaging across rows instead of just listing them one by one. 5 core functions cover most of what you need: count, sum, average, min, and max. The detail worth remembering: count star counts every row no matter what, but count on a specific column skips any row where that column is null. Group by splits your rows into buckets by a column's value, then runs the aggregate separately for each bucket, so instead of one grand total, you get one row of output per genre. You can group by more than one column too. Each unique combination becomes its own bucket. And there's a strict rule worth internalizing: every plain column in select that isn't wrapped in an aggregate has to appear in group by, or most real databases will reject the query outright. Here's the subtlety that trips people up: where filters individual rows before grouping ever happens, while having filters the groups afterward. You need having specifically because an aggregate like count doesn't exist yet at the point where gets evaluated. SQL is written in one order but evaluated in another: from, where, group by, having, select, order by, limit. That's why order by can reference a select alias, and why this final query can filter rows, group them, filter the groups, and sort the result, all in a single readable statement. That's the full entry-level arc: install, select, filter, sort, and summarize, and every later level in this path builds directly on these 5 habits. Every lesson we covered is linked below, in order, so you can run these exact queries yourself and keep building from here.